Okay, so this is from the I think last time I think. Okay, when you have a system of linear equations, there are two ways to look at them. Okay, we'll look at the first typical way that we look at it first. We look at so let's look at the exercise. Look at this example first. Okay, now in this case you have two variables and two equations. Each equation gives you a constraint on the possible value of x and y, right? If you try to plot them out, you get a line from this, one line from this, and if you look at another equation, you get another line. Okay, and if you want to solve this system of linear equations, you want a point or maybe a set of points that satisfy both equations at the same time. Okay. So you need to take the intersection between these two lines, and you get the point here as a solution. Okay. So the first perspective we usually refer to as a row perspective because each equation is one row. Okay. So let's try to use that perspective to solve the first system of linear equation. Okay. I have two questions, right? So let's do the first one first. Okay, so if you do the first, so on the we do the left side first, and then we do the second, the right hand side. So if you do the row perspective, so let's try to do it together. I think you need first. You first need to draw a coordinate. I think. So let's say this one.นี่ยังไม่ได้ทำผมจะไม่เอามาท้ายทำใช่ไหมคราวที่แล้วมีแค่แก้เขาเส้น elimination ใช่ไหมโอเคผมไม่ได้ดูโอเค now so let's try to find a set of x and y that satisfy the first equations. Okay, so to do that how can you find a line? So one equation would be represented as a line. So you can plug in x to be 0. You put x to be 0, y has to be let's say this is y, this is x. So y has to be 4/3, right? So so this is, let's say this is 1. You put on the scale as you like. Okay, so this is like 3/3, right? 4/3, 4/3. So it should be like maybe here, here. So when x is 0, y is 4/3. Okay. When y is 0, x is 2, right? When y is 0, x is 2. So this. Okay. Now you know that it's going to be a line, right? So we plot a line like that. If you have a ruler, then it would be great, right? So, but you don't need it. I mean, you can you can use this your hand. It doesn't have to be that straight line. Okay. The second equation, what do you get? You can say if x 0, y is 4. Right? If x 0, y is 4. If y is 0, x is -2. Right here. Now, after you connect them, it's really hard. ลากไงวะ เดี๋ยวนะครับสักครู่ขอใช้ความพยายามประมาณนี้ like this, and this black line is this set. So let me write it. Is this set xy such that -2x plus y equal 4 is a set. The red line is a set xy such that 2x
plus 3y equal 4. So the solution of this system is this point. Okay. Yeah. So this is for the first task. Now, the second one. So I'll let you work on this one. Okay. So the left hand side is the row perspective. Now we will look at the column perspective. Okay. If you let me give you a quick review. So the row perspective is easy. Is what we already did for many times. But column perspective is a little bit harder. So let me give you a quick review. Okay. So when you look at the column perspective, this system of equations,ฟังนิดนึงครับ Okay. So when you have a system of linear equations, when you think of them as a system, you want to solve them at the same time, right? You want to satisfy both of them, okay? So it's not going to be like we can do whatever we like for the first, we cannot just set x and y for the first equation arbitrarily without thinking about the second equation. So when you look at the column perspective, we sort of like think about the contribution of x and y to the sum here. Okay. This is one way to look at it. Okay. So you want the so you have x and y, right? And you want to set x and y so that the sum according to this formula gives you this 4 and 4, right? When you think of this, you have two variables, but you can think of each variable separately for now. Okay. So when you think of each variable separately, you can see that okay, your goal is 4, 4, right? I'm going to write them as a vector like this, 4 and 4. This is my goal. Okay, I want to get 4, 4. Okay, and what can I do with x? So if you fix an x, right? For whatever x that we have, it contributes 2 units to the top row. Okay, and it contributes minus 2 units to the second row. So you can think of them as just think of x, right? So the contribution of x to this sum of vectors is gonna be this. Okay, you have a value x. X is a real number, right? Value of x. If you increase x, so what does this 2 and minus 2 means? It means if you increase x a little bit, it contributes 2 units to the top row, and it contributes minus 2 units. So if you increase x, you increase the value on the top row and decrease the value on the second row. So this is like what it means, right? And you contribute, you increase and decrease at the same rate. At the same rate, because this is 2 and minus 2, right? If you increase x, the top guy will increase, the top value will be increased, the bottom value will be decreased, but they move at the same rate. Okay. Now, what are the contribution of y? So same thing here. So you can think of the contribution of y. You want as 3 and 1. Now, if I increase y, okay, if I increase y, it increase value of the top row, the top guy, and it also increase the value of the bottom row, right? But now they're not at the same rate. They're not at the same rate. So if you increase y by a little bit, the top row increased by 3 times as much as the bottom row. Okay. So when you want to solve this equation, you can think of this as asking what are the value of x and y, so that these two vectors, this is the first vector, this is the second vector, give you 4, 4. Okay? But we've seen something like this before, right? In this lecture, we've seen something like this before. Okay? So this is a vector, this is also a vector, and this is also a vector. So let's draw them down here. Okay. ผมขอโกงหน่อยครับแม่งรัก เส้นได้ซึ่งไม่ใช้ตั้งนานโอเค alright so let's say 2 and minus 2 so there's no x and y here
because x and y are now variables. Okay, so let's say 2 is the horizontal axis, the top row.
This is the horizontal, this is the vertical. So 2 minus 2 is gonna be 2 and minus 1, 2, 2. This is 2 minus 2. And this 3, 1. So 3, 1. This is 1. Code B of an Okay, so this is 3, 1.
You have 2 vectors. Okay, from here, they're not. Are they in parallel? No, right? So you have 2 vectors on a plane that are not parallel. You can use them to move you to anywhere you like. Okay. In this case, where would you like to go?
4, 4. And where is 4, 4? Our destination is 4, 4. This is 4, 2, 3, 4. This.
How can you reach 4, 4 using 3, 1 and 2 minus 2?
ไปไง ลองประมาณดูครับคิดว่าต้องเป็นไง
So if you only have 3, 1,
what vector can you make out of 3, 1?
what are the vectors that you can create using 3, 1?
That's the span of 3, 1. Okay. So in your work you don't need to call it V1, V2, but let me call it V1, V2 so that I can explain it to you. Okay. So this is V2. Right. So the span of V2, if you just scale 3, 1, you have the span of V2 that look like this.
Okay, the span of V2 look like this blue line.
Okay, the span of V1 is gonna look like this. Okay,
so how can you reach this point?
You would basically need to scale V1. So you need to scale V3 or V2 to this, right? And then you need to scale V1 by some negative numbers so that you can move on that. Right, and then you can reach this point.
Okay, so you can reach this point using these 2 vectors. So it means like 4, 4 is the linear combination of V2 and V1. Okay, but what are the coefficients? You can guess from this. Okay, the solution is going to be the same. Okay, here x is like something like minus something, right, and y is something roughly to 2. So this is like you multiply something like 2 here and roughly minus 1 here to get to 4, 4. Okay. So this is the column perspective
for solving this linear equations, system of linear equations.
So we have 2 vectors, V1 and V2, represent both columns. We have the destination representing this right hand side constraint. And you want to find, to solve for x and y, you sort of like, you want to find that you want to show that you can combine V1 and V2 to reach V4, 4, 4, right? So you want to show that 4, 4 is a linear combination of V1 and V2. Okay. To do so, you show like you scale V2 by this much, and you scale V2 by this much, and you scale V1 by this much minus something, right? And you reach 4, 4. Okay. So 3 vectors. You want to show that the first 2 vectors can be combined linearly to get to the third vectors. So let's work on the second system. If you have questions, you can ask now before we move on to the next one. มีคำถามไหมครับ So you just try to work on it and maybe you get it, and if you don't get it, you can ask me. Okay, I'll walk around. Okay. So the second one, again, we can look at them in column perspective. So this way, so 2, 1, x. The contribution of x, let's say the final value is 7, 1. Right? The contribution of x is 2, 1. The contribution of y to the vector is 1 minus 2 y. Okay. Now, so you have 3 vectors. Okay, you have 7, 1. You have 1, 2, 2, 1, and 1 minus 2. Okay. Try to work on it. Okay, try to do it like this. You need first you draw a coordinate system, and then draw this vector, and then draw 7, 1, and then show that, show how to move according to this direction to reach 7, 1. When you change the variable x, you move along this direction. When you change the variable y, you move along these directions. But our goal is to make sure that the summation is 4, 4. Okay? How can you reach that? Because you only have these 2 directions. You can think of them in either way you like. We can start with V2, or you can also start with V1. But if you start with V2, if you solely use V2, you can move on this line, right? Now, if you want to add V1 gives you these directions. So you basically, if you want to reach to this point, you have to move to somewhere here, and then you follow V1 to this point. Okay? So the solution, when you want to express the solution x and y, so x is like the scaling of this vector in this direction, so it's minus something close to 1. But y is the amount you want to scale V2, right? So it's roughly 2. You can also go along V1 first. ไปตาม V1 ก็ได้นะครับ by looking by thinking about this like this. So because this is V1 can give you to move along this direction, right? And you want to reach this point, and V2 only give you this direction, so you need to reach this point, right? So so to get to this point, so you multiply, you go backward direction from V1 to this, and then you follow V2 to this. Okay. So that's another way to express this that you can do it. Okay. So the amount of scaling here will be x. X is not a vector, but x is the scaling of this vector to reach that one. And you go backward, right? So it's going to be some negative numbers. And then V2 here, you want to go here, so it's roughly 2, right? So this is how you look at them, this equation in terms of as a vector equations. And this is related to linear combinations because these 2 vectors is our vectors, and the right hand side vector is going to be the linear combination of the first 2 vectors. Okay. For here, I think you can really do it, right? So basically, ลองไล่ดูได้ครับก็จะได้เป็นเส้นๆอันนึง so one of 7, 1 is going to be here, right? And 2, 1 is going to be maybe here. 1 minus 2 is going to be here, something like this.
So to reach this point, you need to go this way and then you go down like this. So you need to scale this once and then stuff like that. Then that's it. It's gonna look like this, roughly like this.